Hello, let's solve practice set 1.1. Question first. Base of a triangle is 9 and height is 5. Base of another triangle is 10 and height is 6. Find the ratio of areas of these triangles. Question first. Solution. We have A1 upon A2 equals B1 into H1 upon B2 into H2. Since property of ratio of areas of two triangles. From given information, base of a triangle is 9 and height is 5. Means B1 is 9 and H1 is 5. Base of another triangle is 10 and height is 6. Means B2 is 10 and H2 is 6. That's why let's put these values at the denominator 10 into 6. Now 5 1s are 5, 5 2s are 10, 3 2s are 6, 3 3s are 9. That equals 3 into 1 gives us 3 upon 2 into 2 gives us 4. Therefore, A1 upon A2 equals 3 upon 4. And therefore, A1 is to A2 equals 3 is to 4. That is the ratio of areas of those triangles is 3 is to 4. Question second. In figure BC perpendicular AB, AD perpendicular AB. BC equals 4, AD equals 8. Then find area of triangle ABC upon area of triangle ADB. If you observe diagram carefully, you may note triangle ABC and triangle ADB, they have common base AB, isn't? In case of triangle ABC, AB is a base, BC is a height. Similarly, in triangle ADB, AB is a base and AD is a height. And that's why it is a pair of triangles having equal bases. Okay, let's mention here. Question second solution. From figure, triangle ABC and triangle ADB have common base AB. We have, if B1 equals B2, then A1 upon A2 equals H1 upon H2. And therefore, area of triangle ABC upon area of triangle ADB equals BC upon AD. That equals BC is 4, AD is 8. 4 1s are 4, 4 2s are 8. Therefore, area of triangle ABC upon area of triangle ADB is equals 1 upon 2. Okay? Question third. In adjoining figure, sec PS perpendicular sec RQ, sec QT perpendicular sec PR. If RQ equals 6, PS equal to 6 and PR equals 12, then find QT. We are interested to find QT. Okay. Now, in this triangle PQR, if we consider QR as a base, sec PS will work as height. We know length of QR as well as length of PS. And therefore, using formula for area of triangle, that is general formula, area of triangle equals half into base into height, we can find area of triangle PQR. Now we know that for any base and with corresponding height, areas of the triangle are one and the same for same triangle. That's why if we consider PR as a base, QT will work as height, and therefore by equating those equations we can easily find QT. Okay, that's why let's start a solution of question second. We have area of triangle equals half into base into height. Therefore, area of triangle PQR equals half into QR as a base, PS as a height. That's a half into QR into PS equals half into 6 into 6. 2 ones are 2, 2 threes are 6, and 6 threes are 18 square units. Let's call it as equation first. Therefore, area of triangle PQR equals. Similarly, area of a triangle PQR equals half into. Now with respect to PR as a base, say QT will work as height. That's why we can write area of triangle PQR equals half into PR into QT. Now let's put node values. Just we have area of triangle PQR as 18 square units. That's why we may put here. Therefore 18 equals half into value of PR already given, which is 12. We don't know QT, that we are interested to find. Okay. Now 2 ones are 2, 2 6 are 12. And therefore QT equals 18 upon 6. 6 ones are 6, 6 threes are 18. And therefore QT equals 3 units, or simply we may write QT equals 3. Question 4th. In a joining figure, AP perpendicular BC, AD parallel BC, then find area of triangle ABC is to area of triangle BCD. Let's see triangle ABC and let's observe triangle BCD. Now you may note in triangle ABC and in triangle BCD they have base BC common, and these two triangles lie between two parallel lines. Here AP is perpendicular to BC. Okay, let us suppose say DE is perpendicular to line BC. Now seg AP and seg DE, these are distances between two parallel lines, and we know that distances between two parallel lines are always constant, but these are the heights of these triangles, means these are the triangles having equal bases and equal heights, and we know that a ratio of the areas of two triangles having equal bases and equal heights is 1:1. We are going to apply this property here. Question 4th. Solution. From figure, let DE perpendicular line BC, and therefore triangle ABC and a triangle BCD have equal bases and equal heights. Since they lie between two parallel lines, Okay, we have, if B1 equals B2 and H1 equals H2, then A1 is to A2 equals 1:1. And therefore, area of triangle ABC is to area of triangle BCD equals 1:1. Question 5th. In adjoining figure, PQ perpendicular BC, AD perpendicular BC, then find following ratios. Number 1, area of triangle PQB upon area of triangle ABC. Number 2, area of triangle PBC upon area of triangle ABC. Number 3, area of triangle ABC upon area of triangle ADC. And number 4, area of triangle ADC upon area of triangle PQC. Now let's find these ratios one by one. In triangle PQB, BQ is a base, PQ is a height. In triangle ABC, BC is a base, AD is a height. Means these are the triangles having different bases and different heights. And we know that a ratio of areas of two triangles is equals a ratio of the products of their bases and corresponding heights. That's why we are going to write here B1 into H1 upon B2 into H2 form. Okay. In the case of triangle PQB, BQ is a base, PQ is a height. Let's write here BQ into PQ. And in the case of triangle ABC, BC is a base, AD is a height. That's why upon BC into AD. Since A1 upon A2 equals B1 into H1 upon B2 into H2. Okay. Now let's consider second pair. In a triangle PBC and a triangle ABC, these are the triangles having common base BC. Since in triangle PBC, BC is a base, PQ is a height. In triangle ABC, BC is a base and AD is a height, means these are the triangles having common base BC. And we know that a ratio of areas of two triangles having equal bases is equals a ratio of their corresponding heights. That's why in the case of triangle PBC and triangle ABC, area of triangle PBC upon area of triangle ABC equals PQ upon AD. Since triangles having equal bases and we have, if B1 equals B2, then A1 upon A2 equals H1 upon H2. Let us consider third case. Area of triangle ABC upon area of triangle ADC. Area of triangle ABC upon area of triangle ADC. Okay. In the case of triangle ABC, BC is a base, AD is a height. In the case of triangle ADC, DC is a base, AD is a height. Means these are the triangles having equal heights, and a ratio of areas of two triangles having equal heights equals a ratio of their corresponding bases. Yes, that's why area of triangle ABC upon area of triangle ADC will be equals BC upon DC. Since H1 equals H2, then if H1 equals H2, then A1 upon A2 equals B1 upon B2. Now last and best case, area of triangle ADC upon area of triangle PQC. Now in case of triangle ADC, DC is a base, AD is a height. In triangle PQC, QC is a base, PQ is a height. Means here we are going to apply property of ratio of areas of two triangles. Property of ratio of areas of two triangles. What's that property? The ratio of areas of two triangles is equals ratio of the products of their bases and corresponding heights. In triangle ADC, DC is a base, AD is a height. That's why DC into AD. In case of triangle PQC, QC is a base, PQ is a height. That's why QC into PQ. That as since A1 upon A2 equals B1 into H1 upon B2 into H2. Okay.